Hello viewer, you are watching Elimu TV. Welcome to Form 3 Physics. Our topic is linear motion and I'm your teacher Benjamin Makanda. This is our lesson 1. Stay with me. Specific objectives of the lesson. By the end of this lesson, the learner should be able to define distance, displacement, speed, velocity and acceleration. Describe an experiment to determine distance and displacement. Our lesson preview: define distance, displacement, speed, velocity, and lastly acceleration. Now, linear motion. What is linear motion? Linear motion is also known as rectilinear motion and is referred to as motion along a straight line. Linear motion can either be uniform motion with constant velocity or non-uniform motion with variable velocity or zero acceleration. Now, let's use this diagram here to understand the definition of linear motion and what we mean by non-zero acceleration or constant velocity. So, looking at this graph here is a graph of distance against time. Let's look at the blue lines. The blue lines are starting from the origin of the graph and they show that these objects are moving at a changing speed. The speed is changing with the time. For example, the aircraft over there is moving with changing speed because speed is given by distance divided by time. Now, the red arrow shows that the speed of the object is moving at a low speed and then it accelerates or move at a higher speed with the time. It moves at a higher speed with the time. Then the other black lines there, we have a stationary object because the line is horizontal to the vertical axis, showing that this object is not moving. The object is stationary, while the other one is showing that the object is coming into rest, moving back. The object is coming into rest. So this one can help us to understand what linear motion is, and from the definition we have said, it is also called rectilinear motion, a motion along a straight path or straight line. Definition of terms. So distance is the first term, and this is it is the length of the path traveled by an object. It is measured in meters. It is non-directional and therefore is a scalar quantity. So let's understand the definition from the diagram here. Assuming an object is starting from point O, this object moves to point A, then point B, then point C. You realize from the motion or the movement of this object, it keeps on changing the direction. The direction of motion is not specified, but yet the object is moving. This shows that this object is not moving in any specific direction. And because it covers some length from one point to the other, then that one becomes distance. But distance in which direction? In a direction that is not specified. And that's why we are saying distance is the length of the path traveled by an object, but not in specific direction. So distance is non-directional. And any object that is non-directional, however, it has magnitude or size, we call it a scalar quantity. So distance is a scalar quantity because it only has magnitude, but we don't have the direction. The direction is not specified. So the next one is displacement, and it is the distance traveled by an object in specified direction. It is measured in meters, just like in distance. It has both magnitude and direction and is therefore a vector quantity. It's a vector quantity. Now let's understand this from this demonstration here. Point O to A to B, and D. So we have two individuals who are traveling along this route. One of them is using the green path. The other one is going to use the red path that is actually linear. So this person that is traveling on the green path moves through point O, A, B to D. We cannot tell the direction, but we can actually tell how long this person has moved in terms of length. But we have another individual moving from point O up to point D. So point O to D is a bit directional than an individual moving from point O, A, B, and D. So two aspects come in here. A person moving from point O, A, B to D has covered some distance, has covered some length, but we cannot tell in which direction has he covered this. But this individual moving from point O to D, we can be able to tell he moved from point O to D in the north direction, south direction, so it's a bit directional. So O to D is the distance an object moves in a specific direction, and that one becomes displacement because direction is indicated. However, O, A, B, and D is the length between the 2 points, but the direction is not shown. This is what makes the distance and displacement to be different, and that's why displacement is a vector quantity while distance is a scalar quantity. Difference between distance and displacement. Distance is a non-directional, displacement is directional. Distance is a scalar quantity, displacement is a vector quantity, and I'll explain this. Definition, we have speed. Speed refers to the rate of change of distance with respect to time. As an object moves, it often undergoes changes in speed. For example, during an average trip to school, there are many changes in speed. So, what is speed in mathematically? Speed is given by distance divided by time. And if we manipulate the formula of speed and make distance the subject of the formula, then distance equals speed multiplied by time. We can also derive time from the same formula. Time is given by distance over speed. This means that the speed formula can be used to get other parameters because there are just three: speed, distance, and time. The average speed during the course of a motion is often computed using the following formula. Average speed equals distance traveled divided by time of travel. So this means the average speed during the course of motion is often computed using the following formula. Average speed equals distance traveled divided by time of travel. This means if an object is moving from one point to the other, and along the course this object breaks down, or if it's an individual, the individual rests, when you are calculating the average speed that this object or an individual has covered, we don't put into consideration what happened in between. We just work out the average. We don't look at the time the object was not moving or that. That's why this formula has to be average speed, distance traveled divided by time of travel, including that time that the object was not moving. Example, while on vacation, Kamau traveled a total distance of 440 kilometers. His trip took 8 hours. What was his average speed? So let's look at this. Solution to this: to compute his average speed, we simply divide the distance of travel by the time of travel, and speed is equal to distance divided by time. So Distance is 440 kilometers and our time is 8 hours. If you divide that, you get 5 kilometers per hour. That is the speed with which he traveled. The speed is just expressed as 55 kilometers per hour, regardless of whether Kamau rested during the trip or not. And we can be able to understand this from the explanation that I've just given. Velocity, it's the rate of change of displacement with respect to time. Velocity is given by displacement divided by time. Velocity is a vector quantity. It is direction aware. Differences between speed and velocity. Speed, it is non-directional. Velocity is directional aware. Speed is scalar quantity. Velocity is a vector quantity. A scalar quantity is a quantity that has magnitude but does not have direction. Meaning that speed has size but doesn't have the direction. You cannot tell the direction of motion. So we call that one a scalar quantity. Any quantity that has magnitude but lacks direction, we call it a scalar quantity. On the other hand, vector quantity is a quantity that has both magnitude or size and direction. For example, moving towards north and at a speed of 5 kilometers becomes a vector quantity. Acceleration, it's the rate of change of velocity with respect to time. The SI units of accelerations are meters per second squared. This would mean that if an object has an acceleration of 1 meters per second squared, it will increase its velocity 1 meter every second squared that it accelerates in a given direction. Still on acceleration, if the definition of acceleration is written in mathematical terms, we use symbol A equals to V minus U out of T, and let's just dwell there. A stands for acceleration, V is velocity, final velocity, U is the initial velocity, T is time. Therefore, acceleration is equals to final velocity V minus initial velocity U, all divided by time t. This can be equation number 1. Then solve for V. We make V the subject of the formula. So if we make V the subject of the formula, then V equals to U plus AT, where V is the final velocity, U is our initial velocity, plus the product of acceleration A, all multiplied by time. This one becomes the final equation that explains what acceleration is. And from our explanation, this will be our first equation of linear motion. So up to there, let's look at some of the questions that you will attempt. A superman is off to visit Loin Lane. He sees his sled and increases his flying speed. I know he defies the laws of physics anyway, but let us pretend okay. If our lead-phobic superhero accelerates uniformly from 12 meters per second to 1600 meters per second in 0.40 seconds, then what is his rate of acceleration? This is a question for you. You can attempt it, and then when we meet in our next lesson, we shall look at it, whether you have got it right or not, before we move to our next lesson. Up to there, I've been your physics teacher, Benjamin Makanda. Until then, stay tuned to LMTV. Thank you.